This is Lecture 4 in the FOA series of lectures on premises cabling. In this lecture, we're going to talk about the different types of cable used in premises cabling systems. Structured cabling system standards cover two basic types of cable: unshielded twisted pair and fiber optics. But of course, most premises cabling systems also accommodate wireless access points. So we should really talk about all three. The big advantage of structured cabling standards is the standardization of components that allows interoperability, especially for UTP cable, unshielded twisted pair. Standards cover the designs of connectors and jacks, cables, punchdowns, and the cable itself, all specified in performance grades, from the original Category 3 of 20 years ago to augmented Category 6 that's now available. One thing to remember is all different categories of components are different, and if you mix and match them, you only get the performance from the lowest grade of component that you use. For those networks that still use cable to the desktop, not wireless, you'll find it's mainly unshielded twisted pair. It's used for voice and data, with a minimum of Cat3 cable used for voice, and the majority of installed cabling for data being either Category 5 or 5E. Although newer designs use Category 6, which is needed for 10 gig Ethernet, in its augmented form, Category 6A. Structured cabling standards cover both the cable and the interconnection components. The cable on the left, you can see, has 4 pairs, all with the pairs twisted at different rates, and a separator in the center, all designed to minimize the crosstalk between the pairs. The plug and jack, shown on the right, have to be purchased with a performance grade of the same as the cable you're using, because jacks for Category 3, 5, 5E, 6, and 6A can all be different to meet the performance requirements. The punch-down block on the lower left side is a 66 block, primarily used in older voice systems, and the one on the right is a 110 block, which was more used in data, and is usually the interconnection used on the back of patch panels. Twisted pair cables get their high performance from what's called balanced pair transmission. This means that equal but opposite signals are transmitted along each wire of the pair, so that the equal but opposite polarity cancels the noise emissions. In order to get higher frequency signals, the signals are also encoded like modems for higher bit rates, and multiple pairs are used. For example, from 1000 base T up, all 4 pairs are used to transmit part of the signal that's being transmitted. The performance of the cable itself is determined by the construction, particularly the twists in the pairs. You can see in the telephone wire, an old Potts wire up to the top, there's hardly any twists at all, and the same is true of a Category 3 cable in the middle. But the Category 5E cable in the bottom shows that all the pairs are twisted very tightly and at different rates. So this reduces the crosstalk between the pairs and allows higher frequency performance. In a typical category-rated UTP cable design, you'll find that all 4 pairs are color-coded: blue, orange, green, and brown, and each pair has a solid wire and a striped wire. This is a Category 6 cable with a center divider which keeps the pairs apart and increases the crosstalk performance. Some cabling trivia. What is typically referred to as tip and ring on the 2 wires, where tip is the wire with a stripe and ring is a solid wire, refers to the way that the wires were originally connected to the classic 1/4-inch phone jack. The tip of the plug had the wire with the stripe, and the ring behind that, the second contact, had the solid wire. And that's why we call them tip and ring. UTP cables are designed for various performance levels that are specified according to the TIA-EIA category from Category 3 to Category 6A, and the ISO-IEC class from A to F. The Class F in the ISO specification is what some U.S. manufacturers call Category 7, but until now, Category 7 has not been standardized by the TIA Standards Committee. Up to 100 megabits per second, Ethernet networks could operate using only 2 of the 4 pairs in the cable. But several specialized 100 megabit Ethernet systems were developed using all 4 pairs, and although they never became popular, they provided the base for developing gigabit Ethernet and 10 gigabit Ethernet that actually use all 4 pairs of the cable, transmitting bidirectionally simultaneously. Even types of systems not designed to operate on unshielded twisted pair can be adapted. For example, systems that run on coax can use a balun to convert balanced to unbalanced transmission and transmit it over pairs on the UTP cable. Other systems like token ring or closed circuit TV can be converted using specialized devices. Fiber can even be converted, of course, using media converters. While it's not covered in the standards for unshielded twisted pair cabling, it's possible to cheat and actually use devices that use, for example, 2 pairs for a phone and 1 pair for up to 100 megabit Ethernet. Devices like this have been used for 2 landlines, 2 phone lines, and it works well until you get up to gigabit Ethernet, which uses all 4 pairs. One ideal use for this is in residential systems where you're only working up to 100 megabit Ethernet. Fiber optics is also widely used in premises cabling systems and is included in structured cabling standards. It's used in the majority of large LAN backbones, and it's used in areas like campuses where its longer length capability allows direct links without repeaters. High bandwidth systems, for example, in gigabit Ethernet and 10 gig Ethernet for data centers, and industrial applications for electrical isolation and ground loop elimination, in areas where it has no electromagnetic interference that can bother other systems, or where smaller and lighter cablers are needed. A fiber optic structured cabling system can even be less expensive if it's properly designed using centralized cabling techniques. Structured cabling standards recognize both multimode and single-mode fiber. For multimode fiber, the older 62.5 125, so-called OM1 fiber, is becoming obsolete, and 50 125 OM2 or laser-optimized OM3 and OM4 fiber is more widely used. Single-mode fiber is only used in backbones, mostly on campuses where its longer distance capability makes it a better choice. Most backbones today in premises cabling are multi-mode, with single mode for long backbones only. Fiber optic data links take an electrical signal, convert it to an optical signal using an LED or laser, which it then transmits through the fiber optic cable plant. At the far end, a receiver, which has a detector, a photodiode, converts the signal back to an electrical signal, and signal conditioning then transmits it out as an electrical signal to the communication system for which the link is connected. Most fiber optic systems use LC connectors or SC connectors, with the LC connector preferred for networks operating at gigabit speeds and above. The cabling used can be zip cord, distribution, or breakout cable, and even occasionally loose tube cable. But every type of cable used in premises applications must be rated for flame retardance for use indoors. The electronics used for fiber optics vary from simple gadgets like this wall outlet that is a fiber optic hub, or switches and routers that are rack mounted and have direct fiber optic ports. Wireless has become the connection method of choice for all the users of laptops, tablets, and smartphones because they want mobility. But wireless isn't wireless. What wireless does is replace the typical patch cord with a radio connection. It requires wiring to an antenna, called an access point in Wi-Fi, providing power to that access point. LANs typically use either unshielded twisted pair or fiber optics to connect the access point. Cellular phone system uses antennas typically connected over fiber or coax. Wireless is popular for mobility. For more information on all the types of cabling and, in fact, wireless used in local area networks and other premises cabling applications, go to the FOA website for our online reference guide. Go to www.thefoa.org.